Hey everybody, welcome back. So we're still on the foundations. We have completed 20%. So we're 1/5 of the way towards completing this section. However, I do think that these are going to start getting much more interesting. Okay, so command line basics. Feeling scared of the command line? So yeah, if you just press space, the command bar and then space bar, and you type in terminal, this is where you basically get the command line. 5, 6, 7, 8, 9, 10. Command line allows you to do things like you can go pwd to check where you are, change directories into the desktop. That gives you the kind of root one. Then you can list out what's there. I've only got 2 folders on there. You can change directories into useful programmers. You can change directories back, and then you can touch, which makes a file. You can call this one index.html. And now if you were to list it here, you'll see that there's an index.html here. You can cat index.html, but that's going to give us nothing. So this is basically the command line. So we're going to be learning command line tools. I just raced through it here. My guess is we're going to go through it a lot here. So I just wanted to give you that context initially. So I'm going to close the terminal and we'll get started out again. So are you feeling scared of the command line? You're not alone. We have this image of developers staring intently at black screens with white or green text flashing across the wildly enter incomprehensible commands to hack into corporate mainframes, no doubt while guzzling soda and wiping neon orange Cheetos dust off their keyboard. The black screen or window is the command line interface where you are able to enter commands that your computer will run for you. While there's no need for you to reenact the scene above, working with the command line is a critical skill for you to learn as a developer. The command line is like our base of operations, from which we can launch other programs and interact with them. It has a syntax of its own to learn, but since you'll be entering the same commands dozens of times, you'll quickly pick up the commands you need most. In this introductory lesson to the command line, you'll learn how to navigate around your computer and how to manipulate files and directories, also known as folders, directly from the comfort of your command line. You'll soon see that this isn't as difficult as you may think. The commands you will learn in this lesson are very straightforward, so don't let the prospect of using the command line for the first time intimidate you. Test drive your terminal. Open up your terminal on your computer. For Linux, they say, okay, so I guess with Apple, what you could do is go applications. With Linux, we do, you can open the terminal by pressing Control-Alt-T on your keyboard. But with Macs, you want to go to Applications, Utilities, and then the folder is there. So if you open up Finder, I've never even done it this way. Applications, Utilities. Interesting. Oh, cool. Utilities. Here it is. And then, I've never even done this. Terminal. Cool. That is why I'm excited about this. So you could open it up like that. But the way that I like to open the terminal without having to go through the command line is you just press Command Spacebar and then TER, and then that gets you your terminal. So we'll bump this up in size. All that does, Command 0, is increase the zoom. It doesn't increase the actual font size. The font size doesn't matter in the terminal as far as I know. So before we do anything, take a look at the following text. Who am I? This is the terminal command because it begins with a money sign. That money is saying, hey, enter what follows in your terminal. This means that we must exclude the money sign when entering any command in the example above. We would only enter who am I. So yeah, that's kind of confusing because mine doesn't even have a money sign, and this is a default instance. And so this just shows you, I guess, the name of my computer. Yeah, the name of my computer, and then the good times. I'm not sure exactly. I think we went over that earlier. This means that, okay, in the example above, now that you are aware of what the money sign does, take your terminal for a test run. Make sure your terminal is open, type a command mentioned above, and press enter on your keyboards. It returns your username. Okay, so that was where it returned my username here. Cool. Why learn this now? You will be making heavy use of the command line throughout this curriculum. The upcoming installation projects will need you to install many different software programs using the command line. Additionally, you will primarily be using Git within the command line. More on this later. As part of the bigger picture, you may well be using the command line on a daily basis in your career as a software developer, making it an indispensable skill in your tool set. Agreed. Especially if you get into things like DevOps, you're going to be using the command line religiously. DevOps meaning like when you take a program that you wrote and you publish it to a server that serves it. Cool, lesson overview. This section contains a general overview of topics that you will learn in this lesson. We'll describe what the command line is, open the command line on your computer, use the command line to navigate directories and display directory content, use the command line to create a new directory and a new file, use the command line to rename or destroy a directory and a file, and the command line to open a file or folder in a program. So our first assignment, note that these resources assume that you're using a Mac or Linux machine. If you did previous installation lesson, you should already have Linux installed in dual boot or virtual machine, or you might be using Mac OS. And if you don't have Mac OS or any version of Linux installed, please return to the operating installation guide. Cool. So that's just a little note for people who jumped ahead. So first, it looks like that we're going to go to the Unix shell course designed by the Software Carpentry Foundation. There you will find a full complement of lessons on using the CLI. But for now, just focus on completing the following lessons: setup, introducing shell, navigating directories, working with files, and then pipes and filters. All right, let's check that out. So it says we want to start with setup and introducing the shell. So it looks like introducing the shell. I don't even see setup in here. Actually, I think that's probably an error. Download the exercise files, but skip the software install step. You already have everything you need. So it says that we want to download. The Unix has been around longer than most of its users has been alive. It has survived because it's a powerful tool that allows users to perform complex and powerful tasks, often with just a few keystrokes or lines of code. It helps users automate repetitive tasks and easily combines smaller tasks into larger, more powerful workflows. Use of the shell is fundamental to a wide range of advanced computing topics, including high-performance computing. These lessons will introduce you to this powerful tool. This lesson guides you through the basics of file systems and shells. If you have stored on a computer at all and recognize the word file and directory or folder, two common words for the same thing, you're ready for this lesson. If you're already comfortable manipulating files and directories, searching for files with grep and find, and writing simple tools and scripts, you probably want to explore the next lesson. Well, we're going to keep going through this one. So, download files. Okay, required for the lessons. Here we go. Download the files. You need to download some files to follow this lesson. So, download this one and move it to your desktop. Okay, so I clicked it here, started doing that. As you guys know, my shell downloads go directly to the directory. If yours don't do that, click on Finder and go to Downloads and then drag it into the desktop here. Okay, and then unzip, extract, and let your instructor know if you need help with this step. It's called the shell lesson data. And now if we go to PWD, okay, well first off I want to change directories to the desktop with a capital D. And now if we list it here, you'll see that the shell lesson data is here. So sweet. So the next thing we want to do is go to our desktop and open it up. Okay, looks like there's some data there. And shell lesson data, we have the folder here. So open a terminal. If you're not sure how to open a terminal in your operating, see the instructions below. In the terminal, type CD, then press return key. This step will make you start with your home folder as your directory. Okay, so if we just do CD, and now if we go PWD, we see that we've gone back to the working directory. In this lesson, you will find out how to access the data files in this folder, where to type commands, how to open a new shell. Okay. And then this just shows us how to open it up. Okay, sweet. So we've completed the setup session. And so let's move back to where we started from. I'm going to go back, introducing the shell. So, here we've got introducing the shell. Overview, it's a 5 minutes exercise of 0. What is the command line, why I should use one? Objective, explain how the shell relates to keyboard and screen and operating system and the user's program. explain when and why command line interface should be used instead of a graphical interface. Okay, so for the background, humans and computers commonly interact in many different ways, such as through a keyboard and a mouse, touchscreen interface, or using speech recognition systems. The most widely used way to interact with personal computers is called a graphical user interface. With a graphical user interface, or GUI, we give instructions by clicking on a mouse and using menu-driven interactions. While the visual aid of a GUI makes it intuitive to learn, the way of delivering instructions to a computer scales very poorly. Imagine the following task. For a literature search, you have to copy the third line of 1,000 text files in 1,000 different directories and paste it into a single file. Using a GUI, you would not only be clicking at your desk for several hours, but you could potentially also commit an error in the process of completing this repetitive task. This is where we take advantage of Unix shell. The Unix shell is both a command line interface and a scripting language, allowing such repetitive tasks to be done automatically and fast. With the proper commands, the shell can repeat tasks with or without some modification as many times as you want using the shell. The task in the literature examples can be accomplished in seconds. The shell. The shell is a program where users can type commands where with the shell it's possible to invoke complicated programs like climate modeling software or simple commands that can create an empty directory with only one line of code. The most popular Unix shell is Bash, Born Again Shell, so called because it's derived from a shell written by Stephen Bourne. Bash is the default shell on most modern implementations of Unix, and in most packages, and provide Unix-like tools for Windows. Using the shell will take some effort and some time to learn. While a GUI presents you with the choices to select, CLI choices are not automatically presented to you. So you must learn a few commands like new vocabulary in a language you're studying. However, unlike a spoken language, a small number of words or commands get you a long way, and we'll cover those essential few today. The grammar of a shell allows you to combine existing tools into powerful pipelines and handle large volumes of data automatically. Sequence of commands can be written into a script, improving the reproducibility of workflow. In addition, the command line is often the easiest way to interact with remote machines and supercomputers. Familiarity with the shell is near essential to run a variety of specialized tools and resources, including high-performance computing systems. As clusters and cloud computing become the more popular for scientific data crunching, being able to interact with the shell is becoming a necessary skill. We can build on the command line skills covered here to tackle a wide range of scientific questions and computational challenges. Let's get started. When the shell is first opened, you are presented with a prompt indicating that your shell is waiting for your input. Okay, so this is not the prompt that they're describing, but is essentially the same thing. The shell typically uses bang, which is a money sign. I'm going to call it a bang from now on, as the prompt, but many use, not a bang. I'm going to call it a money sign. But many use a different symbol. In the example for this lesson, we'll show you the prompt as the money sign. More importantly, when typing commands, either from these lessons or from another source, do not type the prompt, only the commands that follow it. Also, note that after you type a command, you have to press enter the enter key to execute it. The prompt is followed by a text cursor. A character that indicates the position of your typing will appear, and the cursor is usually a flashing or solid block, but it can be an underscore or a pipe. You may have seen it in text editor programs, for example. So let's try our first command, ls, which is the short for the listing. This command will list the contents of the directory, so ls. Cool. So as you can see, we got the same thing because we're in the root directory. Maybe not the root directory. If the shell can't find a program whose name is the command you typed, it will print an error message such as KS, command not found. Okay. Nell's pipeline. A typical problem. Nell Nemo, a marine biologist, has just returned from 6-month survey of the North Pacific Gyre. What the heck is the North Pacific Gyre? Nice. It looks like basically the whole area of the northern Pacific Ocean. Or she has been sampling gelatinous marine life in the Pacific Garbage Patch, the Great Pacific Garbage Patch. That's this big area of trash that's out in the middle of the ocean. She has 20 samples that she's run through an assay machine to measure the relative abundance of 300 proteins. She needs to run these 1,520 files through an imaginary program called goosestats.sh she inherited. On top of the huge task, she has to write up results by the end of the month so her paper can appear in the special issue of Aquatic Goo Letters. The bad news is that in order to run goosestats.sh by hand using a GUI, she had to select the open file 1,520 times. If goosestats takes 30 seconds to run each file, the process will take more than 12 hours of Nell's attention. With the shell, Nell can instead assign her computer this mundane task while she focuses on her attention on writing the paper. The next few lessons will explore the ways Nell can achieve this. More specifically, they explain how she can use a command shell to run goosestats program using loops to automate the repetitive steps of entering file names so her computer can work while she writes her paper. As a bonus, once she has put a processing pipeline together, she will be able to use it again whenever she collects more data. In order to achieve her task, Nell needs to know how to, first off, navigate to a file or directory, create a file or directory, check the length of a file, chain commands together, retrieve a set of files, iterate over the files, and then run a shell script containing her pipeline. So the key points. A shell is a program whose primary purpose is to read commands and run other programs. This lesson uses Bash, the default shell in many implementations of Unix. Programs can be run in Bash by entering commands at the command line prompt. The shell's main advantage are its high action to keystroke ratio, in support for automating repetitive tasks and its capacity to access networked machines. The shell's main disadvantage are its primary textual nature and how cryptic its commands and operations can be. Okay, cool. So we're in the shell. Let's move on to the next one. Navigating files and directories. So the questions, how do I move around my computer? How can I see the files and directories I have? How can I specify locations of a file or directory on my computer? So the objectives of this one are to explain the similarities and differences between a file and a folder. It translate an absolute path into a relative path and vice versa. Construct absolute and relative paths that identify specific files and directories. Use options and arguments to change the behavior of a shell command. Demonstrate the use of tab completion and explain its advantages. Tab completion is great. Okay, so the part of the operating system responsible for managing files and directories is called the file system. It organizes our data into files which hold information in directories, also called folders, which hold files or other directories. Several commands are frequently used to create, inspect, rename, and delete files and directories to start exploring them. We'll go to our open shell window. First, let's find out where we are by running a command called pwd, which stands for print working directory. Cool. pwd, print working directory. So that's where we are. Directories are like places, and at any time while you are using the shell, we are in exactly one place called our current working directory. Commands mostly read and write files in the current working directory, i.e. here. So knowing where you are before running a command is important. pwd shows you where you are. Cool. So when we print that out, it shows us we're at my main working directory. This computer's name response is users Nell, which means it's Nell's home directory. So the home directory variation. The home directory path will look different on different operating systems. On Linux, it may look like home/Nell, and on Windows, it will be similar to documents and settings Nell or users Nell. Note that it may look slightly different from different versions of Windows. In future examples, we've used Mac output as the default. Linux and Windows output may differ slightly, but should be generally similar. We will also assume that your pwd command returns you to the user's home directory. If pwd returns something else, then you need to navigate there using cd command in the lesson will not work as written. See exploring other directories and details by using cd. To understand what a home directory is, let's have a look at how the file system as a whole is organized. For the sake of this example, we'll be illustrating the file system in our scientist Nellie's computer. As after the illustration, you'll be learning commands to move your own file system, which will be constructed in a similar way, but not exactly identical. So on Nell's computer system, we have the root directory. There's bin, data, users, and temporary. At the top of the root directory, the root directory holds everything else. We refer to this using a / character. On its own, this character is the leading slash in users/Nellie. So what does that mean? If we were to just change directory to the root, you'll see that we're back. It looks like we're at the same place, pwd. Yeah, so that's actually different than that one. And so in order for me to get back to the desktop, I think I could go change directories, desktop. Yeah, and that would get me back there. But if I change directories to here, I go all the way to the root directory. And that has the lists of all my folders. So that would be their temp, user, and bin. Okay, and inside there's multiple different directories. Bin, which is where some built-in programs are stored. Data, for miscellaneous data files. Users, for users' personal directories are located. And temporary, or for temporary files that don't need to be stored long-term, and so on. We know that our current working directory, users/nell, is stored inside users because users is the first path of its name. Similarly, we know that users is stored inside the root directory because its name begins with a /. Okay, so slashes. Notice that there are two meanings for the / character. When it appears at the front of the file or directory name, it refers to the root directory. When it appears inside a path, it's just a separator. So underneath users, we find one directory for each users with the account of Nell's machine, her colleague Imhotep and Larry. So she's got Imhotep, Larry, and Nell. Those are subdirectories of the user directory. The user's Imhotep files are stored in user/Imhotep. User Larry's is in user/Larry, and Nell's are in user/Nell. Because Nell is the user in our example here, therefore we get user/Nell as our home directory. Typically, when you open your new command prompt, you will be in the home directory. So now if we were to go pwd, list where we are, then, so what they're saying is this is kind of our main root structure. So this would be the root. And so what we want to do is check into our user. So we can go user cd users. And I'm pressing tab to autocomplete. And now if you list here, you can see they're shared and I'm the only user here. Okay, cool. Now let's try to learn the command that will let us see the contents of our own stuff. We can see what's in our home directory by running ls. So if we go ls, well, what they want to do is change to nell. And for our example, it's going to be my home directory. So I'm going to change directories into there. And now we can ls, and we'll see here. And then we have our desktop and Adobe applications, and our Visual Studio Code would be in here. And so this is the output from doing the ls. It looks like we're on the same page. So again, the results might be slightly different. Yeah. ls prints the names of the files and directories in your current directory. We can make it output more comprehensive by using the -f option, which tells ls to classify the output by adding a marker to the file and directory to indicate what they are. So ls-f. Okay, it looks like because they're all directories, that did it there. So if we were to change directories into the desktop and the ls-f, looks like we're still getting that. I wonder what's that. Seems like it just adds the / on. So yeah, that tells us that it's not. These are folders and these are not. Cool. Here we can see that the home directory can contain only subdirectories. Any names in our output we don't have a classification symbol for are plain old files. If your screen gets too cluttered, you can clear your terminal by using the clear command. So if we wanted to clean this up, we can go clear. Yeah. And now I know another one that you can do in terminal is you can press Command K. ls has lots of options. Let's just go pwd and ls. We can pass -- help options to the command line, such as ls-help. Interesting. we can read its manual with man command. Man ls. Okay, so this would give us the manual for that. It's interesting that ls that. Oh, it's not available on Mac OS. So yeah, this manual here would have a listing for recursively list subdirectories. You can do all sorts of wild things. But this, I think, would be considered a wormhole to go down at the current time. So the -- help button. Okay, because this doesn't relate for Mac, I'm going to skip this. But ls, like man ls, gets you this output that they're looking for. Cool. So what's up? I wonder. Yeah, ls-j. It says it's an invalid command line. Okay, cool. So it's just telling you that the man is the way you can do it. So you can go man ls, and that'll do you. I wonder if you could do like man change directories. Yeah. So all these things have tons of documentation. You can read the manual for all these commands. I've never really gone that deep into it though. To navigate through man pages, you may use up and down to move line by line. So let's go man ls. And so I'm pressing down, pressing up. That'll move me through them. Or try B and spacebar to skip up and down the full page. B spacebar. Cool. That's getting us down the whole page. To search the characters in the manual, use the / followed by the character or word you are searching for. So you could go man ls / help maybe. Okay, maybe it just means like in here, multi-column. Nice. So yeah. Oh, cool. So you can just search for words in here. Like here, I see it says symbolic link. / SYMBOL, and then it would show me that one. Cool. I actually didn't know that. I didn't know you could do / and then search for something. Say if I wanted to go to the root, it said pattern not found. Okay. Followed by the character. If so, we can move between hits using N for moving forward and Shift N for moving backwards. Oh, okay, cool. So if we go to symbolic, there we go. And then we can go N to move to the next one, N to move to the next one, or Shift N to move back. Oh, that's interesting. Man, I hope I can remember this stuff. Manual pages on the web. Of course, there is a third way to access help commands. Oh, and to exit here, press :Q, and that'll get you out. Manual pages on the web. Of course, there is a third way to access help from your web browser using the internet search. Include the phrase Unix main man page in your search query, and you'll be able to find it. Okay. You can also use two options at the same time. What does the command ls do when you add the -l option, and what does it use when you go -l and -h? So ls-l gives you, it looks like it gives you the name of the files and details about maybe when they were started. And then if you do h to it, looks like it gives you the name of the files, and yeah, it doesn't look like H did much. Total 904. So let's look at the solution. The -l option makes ls use a long listing format showing not only the file directory but also additional information such as the file size, the time of its last modification. If you use -h and the -l, this makes the file size human readable, i.e. displaying something like 3.5K instead of 356. Oh, cool. So that here it was 460, and here it's or they just have it there. So these are human readable size file sizes than the other ones. Listing in by ls. Okay. Listing in reverse chronological order. By default, ls lists the contents of a directory in alphabetical order by name. The command ls-t lists the items by time of last change instead of alphabetically. This command ls-r lists the contents of the directory in a recursive order, in a reverse order. which files is displayed last when you combine T and R. Hint, you may need to use -L option to see the last changed. Okay, so ls -L -T and -R. We do it that way, it looks like they're organized by their most recent creation. The oldest one first. Interesting. Let's see what it says. The most recent changed file is listed with last with using -RT. Oh, okay, so ls-RT. This can be very useful for finding your most recent edits or checking to see if your new output was written. Exploring other directories. Okay. Now, not only can we use ls in the current working directory, but we can use it to list the contents of different directories. Let's take a look at our desktop directory by running ls-f desktop. ls-f desktop. Okay, so it doesn't want like me doing that. I think it's because I'm actually on the desktop. So ls-f desktop. Okay, and I use the tab again for autofulfill. The command ls with the -f option and argument. This argument desktop tells ls that we want a listing of something on other than our current working directory. So the reason that didn't work, it was because I was in the current working directory. So here we go. Cell lesson data, that's there. Note that if a directory named desktop does not exist on your current working directory, this command will return an error. Typically, a desktop directory exists in your home directory, which we assume is the current working directory of your bash shell. Your output should be a list of all the files and subdirectories in your desktop directory, including the shell lesson data directory that you downloaded in the setup lesson. Okay, so if we list that now, well, we need to change it to our desktop. And then when we list it, we have our shell lesson data. We can do two things. First, we can look into the contents using the same strategy as before by passing the directory name to ls. So we could do that. Yeah, we could do ls shell lesson data. And that will give us this the two data points they want. Second, we can actually change our location to a different directory so we can no longer locate it on our home directory. The command to change locations is cd, followed by a directory name to change our working directory. cd stands for change directory, which is a bit misleading. The command doesn't change the directory, it changes the shell's idea of what directory we are in. The cd command is akin to double-clicking a folder in a graphical user interface. Let's say we want to move to the data directory we saw above. We can use the following series of commands to get there. So yeah, if we check out where we are, we're on the desktop, so we don't need to change directories into desktop. And if we list what we have, we can change directories into our shell lesson data. And now if we list there, we have our exercise data. So pwd and ls. That just tells us we've got our shell lesson data, and this is the data that's available to the place where we are located. Here it says they want to change directories into exercise data as well. So now we have more data. These commands will move us, and this, just to be totally clear, if you're coming from a graphic user interface, this is just like going like here to the exercise data and then listing out these guys. You've got your creatures, proteins, writings, number, and that. So that's the exact same thing. It's just moving around like this with your pointer key. These commands will move us from the home directory into our desktop directory, then into the shell lesson directory, and then into the exercise directory. You will notice that cd doesn't print anything. This is normal. Many shell commands will not output anything to the screen when successfully executed. But if we run pwd after it, we can see that we are now in it. Current working directory. If we run ls-f without arguments now, it lists the contents of the folder. Because that's where we are now. And yeah, pwd ls-f. So that looks to be exactly what's happening for us. We now know how to go down the directory tree, but how do we go up? So we might try the following. So this doesn't get us there. So if we were to just try to change directories into our shell lesson data, we get no directory. But we get an error. Why is this? With our method so far, CD can only see subdirectories inside your current directory. There are different ways to see directories above your current directory. We'll start with the simplest. There is a shortcut in shell to move up one directory, and it looks like this. So if we go pwd, you'll see we're in our exercise data, and if we go cd and go up, and now we go pwd, you'll see that we've gone out of the exercise data. So that just takes us out. And now we're in the shell lesson data. Here we go. This simple special the special directory ... doesn't usually show us when we use ls, and if we want to display, we can do -a option to f. So ls-f-a. Cool, and that actually shows us the dots. A stands for show all. It forces ls to show us file and directory names that begin with a period. So yeah, later on we can use -a to find git files. As you can see, that also displays another special directory called dot, which means the current working directory. It may seem redundant to have a name for it, but we'll see some uses for it soon. Note that this is the most common command line tools. Multiple options can be combined with a single dash and no space between the options. Oh, cool. So ls-a, I think that would work just the same like that. Nice. Other hidden files. In addition to your hidden directories, you may also see .bash profile. This file contains shell configuration settings. You may see other files and directories beginning with dot. These are usually files and directories that are used to configure different programs on your computer. The prefix dot is used to prevent those configuration files from cluttering the terminal when the standard ls command is used. These three commands are basic commands for navigating the file system of your computer: pwd, ls, and cd. Those are the ones you want to really remember. Let's explore some variations of these commands. What happens if you type in cd on its own without giving a directory? Well, we could just find out. If we do cd, pwd. Okay, so just cd changes us straight to the user root file. It turns out that cd without an argument will return you to the home directory, which is great if you're lost in your own file system. Let's try returning to the exercise data directory from below. Last time we used three commands, but we can actually string them together the list of the directories to move to exercise data in one step. So yeah, change directories, desktop, and then pressing pound in order to autofill it, right? Exercise data. And so now we're back in the exercise data. Check that we've moved to the right place by running pwd and then ls-f. Nice, and that shows our files. If we want to move up one level of the data directory, we could use cd ... but if there is another way to move to any directory regardless of your current location. So far, when specifying directory names or even a directory path as above, we have been using relative paths. When you use a relative path with the command like ls or cd, it tries to find the location from where you are rather than from the root system. However, it is possible to specify absolute path to a directory by including its entire path from the root directory, which is indicated by a leading slash. The leading slash tells the computer to follow the path from the root of the file system, so it always refers exactly to one directory, no matter where you are when you run the command line. This allows you to move to our shell lesson data directory from anywhere in our file system, including inside exercise data, to find the absolute path we're working for. We can use pwd and then extract the piece we need to move to shell lesson data. Okay, so let's check this out. I'm going to close this for now, so we're not really using it. Okay, pwd. We're currently in the exercise data. And then, okay, so if we wanted to change to our shell lesson data, we could always just go change directories /users /ian /desktop /shell lesson data. And that would get us there. This is called an absolute path. Whereas if we were to just have gone change directories like that, that would be a reference path. Okay, 2 more shortcuts. The shell interprets the tilde character at the start of the path, meaning the current user's home directory for the example. If nell's home directory is user's nell, then /data is equivalent to user/nell/data. This only works if the first character in the path, here, there, whatever, elsewhere, is not here, there, user's elsewhere. Okay. So if we were going to go change directories with the tilde, then where would we end up? Right at the user's path. And that's why a lot of times you'll see me go change directories tilde and then /desktop, and that'll just get me to my desktop. The difference between CD another shortcut is the dash character. CD will translate dash into a previous directory I was in, which is faster than having to remember then type the full path. This is a very efficient way of moving back and forth between 2 directories. If you execute CD dash twice, you end up back in the starting directory. Cool. So pwd, I'm at the desktop. So what happens if I change directory into exercise data? And now if I go CD dash, I should be back at the root. Cool, I'm at the desktop. And if I go change directories dash, I'm back at the exercise data. Cool. The difference between CD ... and CD dash is that the former brings you up while the latter brings you back. Try it. Navigate there, CD lesson data, exercise data. Oh, cool. I did it exactly the way they thought. Absolute versus relative paths. Start from users. Users. Which is the following command could Amanda use to navigate to her home directory? Which is /users Amanda? She could use the CD ... she could just use a combination of all of these. If she's starting from there, which of the following commands could Amanda use to navigate to her home directory, which is users Amanda? CD ... number 9. Oh, okay, cool. You can go through each of them. User home directory. So yeah, using no, that'll keep her in the same directory. Using a /, that takes her to the root directory. That's pretty far away. If you did home / home/Amanda, that wouldn't work because home directory is users. So that's a misnomer. Home wouldn't work. It wouldn't match. Number 4 ... No, this command goes up 2 levels to users. Yeah, this would go 2. So she'd be at Amanda and then users. So she'd be not where she wanted to go. Just CD tilde. Yeah, that would do it. Okay, yeah. Because if I was here and I did pwd, I'm in the exercise data. And I just did change directories, then ls pwd. That's where I want to be in my users directory. And so that's where we're trying to go. So that's what they're trying to say. There's more than one way to move everywhere. CD home 6, I don't think that would work. This command would navigate into the directory home, and the current directory exists, if it exists. I don't think that this exists on mine, so I would get a no such file, and so would she probably. Tilde /data / ... Okay, sure. That would get her to this one, but why would she unnecessarily complicated, but it would get you there? Yes, shortcut to go back to the user's home directory. Oh, she could just use CD. We can change directories to get back to where I was. If I pwd here and I just did CD, that would get me to the home directory. All right. Relative path resolution. Using the file system diagram below, if pwd displays users/thing, so that means our current working directory is here, what will ls-f ... /backup? Okay, so list, and it's going to check the file, it's going to format the file, and it's going to check the one that's backed up, and then /. So it's going to display original pnas _ final pnas _ stub. Number 4 is the solution. Oh, cool. I didn't know I was saying it could be both of them. But it looks like we got that right. There's no directory for the first one. ... backup. Backup : in users. Oh, that's just pulling up the file. You need to change directories in order to list it. I guess I don't really understand why they would think that the dates would come in here. But anyways, the answer is number 4. Yes, .backup refers to user's backup. Cool. LS reading comprehension. Using the file system diagram below, if PWD displays user's backup and -R tells LS to display things in the reverse order, what commands will result in the following output? So, file system, if PWD displays backup, so if we're here, we're here in this backup section, user's backup, yeah. Not to be confused with user's thing backup, but user's backup. And R tells LS to display things in reverse order, what command will result? I think PWD will not do it. I think it'll just be in regular order. LS-R-F, that might place it in reverse order. This one I think this one will work as well, but I think it's needlessly complicated. So, out of order, in order, but needlessly complicated. PWD is not the name of a directory. Oh yeah, I should have known that. The only way to get that to work would be to make a directory to PWD. That wouldn't work. Okay, so yes, LS without the directory argument lists the files and directories in the current directory. Yes, uses absolute path explicitly. So this, I don't know, maybe this would be good. If you're writing a program and this was just going to show up in different locations in the system, that might be a more robust way to do it. Okay, cool. General syntax of a shell command. We have now encountered commands, options, and arguments, but it perhaps useful to formalize some terminology. Considering the following below as a general example of a command, which we will dissect into the component parts. ls-f. So you've got your prompt, your command, your option, and your argument. ls is the command with the option of f, and the argument is a /. We've already encountered options which either start with a single dash or 2 dashes, and they help change the behavior of a command. Arguments tell the command what to operate on, e.g. files or directories. Sometimes options and arguments are referred to as parameters. A command can be called with more than one option and more than one argument, but a command doesn't always require an argument or an option. You might sometimes see options being referred to as switches or flags, especially for options that take no argument. In this lesson, we will stick to using the term option. Each part is separated by spaces. If you omit a space between ls and -f, a shell will look for a command called ls-f, which doesn't exist. Also, capitalization can be important. For example, ls-s, lowercase s, will display the size of the files and directories alongside the names, while ls-uppercase s will sort the files and directories by size as shown below. And so here they show below their listing -s with the exercise data, and it just shows 4 animal counts. Note that the sizes returned by ls-s are in blocks, as these are defined differently for different operating systems. You may not obtain the same figures as in the example. So pwd, let's go cd dash. That gets us back to the exercise data. And it's saying if we go ls-s exercise data. ls-s. Okay, cool. So yeah, our results are different. We have different numbers. And now if we go ls-S exercise data, we don't need to put that in because we're in the exercise data. Then it just shows us these in order somehow, I guess. Putting it all together, our command above gives us a listing of files and directories in the root directory. An example of our output might get from this command. And then this one we're just saying the root directory. Okay, so obviously it's a little different for ours. All right, I'm getting close on this one. Nellie's pipeline organizing files. Knowing this much about the files and directories, Nellie is ready to organize the files and that the protein assay machine will create. She creates a directory called North Pacific jar to remind herself that the data, where the data came from. ls. Okay, North Pacific jar. So we already have that in our data set, and I'll just clear this out so it's clean. Command K to clear. The command is a lot to type, but she can let the shell do most of the work with a tab completion. Okay, cool. So if she were to list out the north, she could just go NOR and then to hit the tab key, and that's how you get those. And so then we can look at our data files. Yeah. Pressing tab again does nothing since there are multiple possibilities. Okay. So ls and North Pacific jar, and then if we hit tab again, there's lots of different possibilities. So all those files come up, but we could still use this as a way to look it up. So, yeah, it's useful. So right now, if I wanted to say look at specifically Goose stats, I can press tab, and that will fill me in. And because there's still multiple options, I still need to look. And so once it's like that, then we can just list that. But because this is a shell file, it's not going to list what's in it. It needs to show directories. Cool. This is called tab completion. We will see it in many other tools as we go on. Cool. So the key points. The file system is responsible for managing information on the disk. The information is stored in files, which are stored in directories. Directories can also store other directories, which then form a directory T. PWD prints the current user's working directory. LS, and then a path argument, prints a listing of specific file or directory. LS on its own lists the current working directory. CD path, and then your path is your directory that you want to move to, changes to the current directory. Most command takes options that begin with a single dash. Directory names in a path are separated with a / on Unix, but a / on Windows. / on its own is the root directory of the whole file system. An absolute path specifies a location from the root of the file system, and a relative specifies a location starting from your current location. Dot on its own means current directory, and ... means the directory above that one. Cool. What manual page do you want? Interesting. All right. That's good for that one. So we've completed the navigating files and directories. Let's see what the next one looks like. Working with files and directories. So this is going to be another long one. I think I'm going to have to break this video up into multi-parts. So let's go back to the Unix shell. We've gone through, what did we just come through? We moved up to working with files and directories. Working with files and directories. So we completed the navigation point. And now we're going to work with files and directories. So this is another 30-minute one. So I'm going to break up this command line basics into multiple parts. So our command line basics right now, we want to, our next one. So we completed all the way up to here. So 1.3. And so once we get back down here, we're going to continue this one on. Yeah, this video looks like it could stretch for maybe 2 or 3 videos, but we'll see how it goes. But for now, we've completed up to navigating files and directories. And in the next video, we'll start with working with files and directories. Thanks for watching, guys. See you in the next video.